Okay, let's take a look at Explore 2 from our Physics 2.1. We'll start by drawing our template for the Cornell notes. Okay, go ahead and write down your date. And the essential question is going to be in green here. What is plasma? And how does it compare to other states of matter? Okay, so you already know you should be thinking to yourself solids, liquids, gases, the states of matter you're most familiar with. Perhaps you are aware of plasma as being a fourth state of matter. So, what makes it different from your solids, liquids, and gases? Okay, so what I want you to do is I want you to take a minute and write down what you know, what I know, and as always, or think. If you don't know, take a chance and tell me what you think, okay? And spend just a minute doing this, okay? Remember that this question is part of your formative homework assignment, okay? And so you're going to spend a minute writing what you know now, and then when you do your summary sentence at the end of our notes, hopefully you're going to add more detail, and that'll help you answer your homework question, okay? Okay, well, let's go ahead and begin. Roman numeral 1, plasmas. And we're consulting the text for our information. And in this first section titled Plasmas, we see the first paragraph talks about subatomic particles interact through the four fundamental forces. Remember, those are gravitational forces, electromagnetism, strong and weak nuclear forces. Your subatomic particles interact through all of those forces. And that allows these particles to combine. That's kind of an important part there. Um, it allows the particles to combine into bigger things, such as atoms and molecules. These are the things that make up you and I, and the desk you're sitting at, the TV you're watching, right? So all of these are made from subatomic particles. We're talking about protons and neutrons and electrons and quarks and neutrinos. And all of those are interacting based on magnetism, electromagnetism, and gravitational forces and strong and weak nuclear forces. Okay, it's interesting. Um, if you move on to the next paragraph, you can see that I've highlighted the key point. And remember, please, please, please read this stuff. Don't just rely on my highlights. You're not going to develop your skills if you don't read it yourself. Plasma is a state of matter similar to a gas. So that's probably the essential thing we want to write down here. Plasmas. A state of matter similar to gas, to a gas. Okay. All right. Well, how is it different than a gas if it's similar? You know that gas particles in a gas, they move very quickly, right? Faster than a liquid. Um, they have enough energy um, that they resist being connected to other atoms or other molecules. In a gas, Particles form electrically neutral combinations of atoms or molecules. Okay. Okay, so a little refresher here. Remember, and we're just lifting this directly from paragraph 2, right? Gases form electrically neutral. Neutral means no charge. So a gas, um, whether it's an atom or a diatomic structure, two atoms, or whether it's a molecule, they don't have positive or negative charge. They are neutral. Okay? Electrically neutral combinations of atoms or molecules. Okay. Third paragraph. The difference is that atoms in plasma do have a net electric charge. That's the important difference. They do have a net electric charge. Okay. So plasmas, they're a state of matter similar to gas. Remember, gases form electrically neutral combinations of atoms or molecules. Versus plasmas, which do have a net electric charge. That means at the end of the day, when you add up the protons, which are positive, and you add up the electrons, which are negative, um, they're not going to balance out. You're going to have either more protons or you're going to have more electrons, and that's going to make you more positive or it's going to make you more negative. Okay? We'll put this as a little note to ourselves. Remember, dot, dot, dot. An atom can pick up an electric charge if it loses an electron. Okay? An atom can pick up an electric charge if it loses an electron. Okay. Okay, we would call this an ion. And remember, in this case, it would become a positive ion, and we call these specifically cations. Okay, because it would have more positive charge. Okay, that's if it loses an electron. So an ion is an electrically charged particle. Plasma is like a gas of charged particles, positively charged ions and negatively charged electrons. Okay. Um, so let's go ahead and just bring our thing down here, kind of continuing our template, right? And what do we want to say here? Um, Therefore, or plasmas are like a gas of charged particles. And this is going to be a combination of things. It's going to consist of positive ions, both positively charged ions. And remember, if they lose the electrons and become positively charged ions that way, then you're going to have a bunch of negatively charged electrons just floating there. And negatively charged electrons. Okay, that's kind of it, really. That's your working definition of plasma there. Okay. Interesting here, this next paragraph. Plasmas are not common on Earth, not as common as solids, liquids, and gases. But in the universe, they are the most common. Plasmas are by far the most common state of matter, not on Earth, but in the universe as a whole. In fact, the sun and other stars are giant balls of plasma. Okay? Side note. Okay, side note. Although plasma is not too common on Earth, we don't see a lot of it. Um, Although it is not too common on Earth, it is the most common state of matter in the universe. That's pretty interesting, isn't it? For all the things that you've learned about solids and liquids and gases, the most common state is plasma, not necessarily on Earth. Now, on Earth, where do we find plasma? Well, lightning is a form of plasma, as your text describes. Neon lights are examples of plasmas. Okay. Make sure you watch that video, okay? So to create a plasma, you have to heat a gas, okay? So let's see if I can shift this over here. Creating plasmas requires the heating of a gas. If you can get that gas to absorb enough energy, it's going to start uh, to move. The particles are going to start to move faster and faster. And if you can impart enough energy, you can actually cause the electrons to break free of their orbits, right? Because they're attracted to the positive protons, right? So the atoms become ionized when the atoms gain enough energy and lose electrons. So it requires the heating of a gas which excites the atoms such that they lose electrons. Okay, that's kind of it right now. Okay, so obviously the temperature is going to be very hot, right? And in this video here, you can see this person who is creating plasma. Looks just like lightning, huh? And there you go. You can see in the next paragraph, lightning is plasma created by friction between moving particles within a cloud. Plasma TVs use plasma. Okay. Plasmas in neon lights and common fluorescent lights also use plasma. Okay. Some examples of where we see plasma, right? Okay. Well, believe it or not, that's it on our notes. Okay, so that's the idea of plasmas. Make sure you watch these other videos, The Core of the Sun, the Princeton Plasma Physics Laboratory, and also reading extra reading, the Plasma Everywhere passage. Okay, all right, what I want you guys to do right now is I want you to go ahead and just write me a summary paragraph. Okay, just take a couple minutes and summarize what you know about plasmas now. Hopefully you know a little bit more than you did when you started this video, and then answer that question inside your Explore 2, okay? Because I think you'll be ready for it. All right, good luck, and we'll talk to you soon.